freecoachingtoday.com.
So this is problem number 5 from SC Verma's physics in chapter 11 of gravitation. There are 4 masses. They move along the circle of radius r under the action of their mutual gravitational attraction, and we need to find out the speed of each particle. So basically we make an assumption that these 4 particles are symmetrically placed along the circle. And this assumption should hold because the moment we disturb the symmetry, the mutual forces of attraction, which are equal in amount, will create a disturbance in such a way that it will try to maintain an equilibrium. With this assumption, we need to find out the forces acting on this particle due to the other 3 particles. This force is going to be along the center, as we will see later. Now the centripetal force acting on this particle is given by mv square by r. We will make an equation which will equate this force with the equivalent mutual gravitational attractional force. Now let's see what this force is going to be. The force acting on this particle due to this mass m has a total distance of 2r. And this force, let's say, call it particle 1, 2, 3. So this force F2, and it acts only on the y-axis direction or in this axis direction, so we'll call it F2y, is equal to g m1 m2, which is m square divided by 2r whole square or 4r square. Now let's say what's the force acting on this particle due to this one. This force, it's shown along this direction, will have 2 components. One component is the result on the horizontal x-axis, and the other will be acting on the y-axis. In the same way, we can join this line, and the force acting on this direction will have 2 components, one along the x-axis, other along the y-axis. The x-axis components, due to this pole and this pole, they work in the opposite direction and they cancel each other. So the resultant force is only the one that acts along the y-axis. So we find out F1y as this angle. Let's say we call it this angle, and we know the magnitude of this angle because this is r, this is r. So it's a right angle triangle, and this angle is 45 degree. Now this force F1y is given by g m1 m2 r square divided by this distance is root 2 r, and its whole square is going to be 2r square, and then multiply it by this angle to cos theta, cos 45, or for that matter sin 45, which is 1 by root 2. And then F2y, same thing for this force due to this mass, resolve along y-axis. That will be given by g m square divided by 2r square into 1 by root 2. If we add these 3 forces, we'll get the total force acting along the y-axis as g m square divided by 4r square plus 2 into this force g m square divided by 2r square into root 2. The 2 gets cancelled, and we get g m square divided by r square 1 by 4 plus 1 by root 2. If you want to, we can simplify it a little bit more, but that is what it is. Now we equate this force with this. Note that the total net force is acting along its center. Now this force is equal to this centripetal force m v square divided by r. This m gets cancelled, then r gets cancelled, and we have v square is equal to g m by r multiplied by 4 root 2 plus 4.